Okay, I think we should start. And today is the 28th. Uh-oh. See, I'm way ahead of everybody by 2 years. Okay, so 2x squared raised to negative 3, negative 3x to the 4th power. Please assign yourself a 0 if you don't get the correct answer. And you don't have to show it to me. But that will tell you, oh, I need to study hard in this class. Okay, so first of all, I will have to raise 2 to negative 3. I will have to raise x squared to negative 3, which is negative 6. Copy the base, multiply the exponents. Then I multiply negative 3 by itself 4 times, or I say negative 3 to the 4th power, which is 81. And then x power 1 times 4 is 4. Is this step clear so far? Okay. Now, I will definitely multiply these two, copying the base and adding the exponents, but in this case I have x to negative 2. And then this changes into 1 divided by 2 cubed, which is 1 over 8. 1 over 8 times 81 over 1 is 81 over 8. I'm not allowed to leave negative exponents in the final answer. So then again, this is nothing else but 1 over x squared. So therefore, the final answer is this. Any questions on this problem, please? Okay, we are working on E, correct? Which is x to the 3rd minus 7x squared minus 4x and plus 18. We're asked to factor completely. How are we doing with this problem? Raise your hand if you have questions. Are we okay? Do we remember how to factor this? Do we need more time? Please talk to me, say anything, I'll accept anything, any answer. My grandma used to say, if you ignore somebody, you crash his or her heart. So don't ignore me, please. So, say it again? Okay. Does anyone have an idea about how to factor? What is the procedure? How do we think about it? Just anything. What are we factoring, first of all? That's very important to know. We are factoring what? A polynomial. Okay. How many terms does it have? Careful. How many terms does it have? How many terms does it have? 4 terms, correct. 1, 2, 3, 4 terms. Good. How do we handle factoring of a polynomial with 4 terms? It's called, thank you, grouping. Good. So the convenient way to group is this and this. It doesn't necessarily mean it's going to work. So if it doesn't, then I will have to go back and group these 2 and these 2, or maybe these 2 and these 2. I don't know. I'm hoping that this, in descending order, it's in descending order already. I'm hoping that this works. So what do I factor out from the first two terms? Good. What is left in parentheses? Good. I refuse to look at the other two. What do I have to have in parentheses coming out from the other two before I even look?
X minus 2 or 7.
X minus 7. If I don't have x minus 7, I will not be able to continue. Let's see if it's there. I cannot make it up. Is it there? And the answer is?
Oh, that's supposed to be 28.
Yeah.
Oh, I copied 18. I'm sorry. Good. Very good. Now I pull out the common factor, which is x minus 7. And then?
X squared minus 4.
Good. And I have an agreement. So what do I do next? Good. Excellent. How do I factor that?
On the agreement, you do x plus 2 and x minus 4.
Good. And I just want to draw your attention to 1 second here. I'm going to show you how nothing special at all. You just, I'm going to give you the syntax. So I wrote factor, left parenthesis, right parenthesis, and all commands in Maple have to end with a semicolon. So I put in the x cubed minus 7x squared minus 4x plus 28. Maple does not recognize something like this. So you have to put the multiplication symbol. And then I'm going to click enter. Nice? Okay. Good, so let's continue then. We are working on E. We chose E. And what is E and how do we call it? What is it and what type is it? What is it? We're asked to solve. What is it that we are solving? What we are solving for? We are solving for x. But what is it? What is this? An equation. Very good. What type of equation? So we established that this is an equation. It's not an inequality, it's an equation. Perfect. And what type of equation is this? How many types we know? Many. But just name a few. How many types of equations we know? Just
Quadratic.
quadratic is one type. Good. Another one? Anyone remembers any other type of equation? Quadratic is a good example. Anything else?
Linear.
Linear, excellent, perfect. Excellent, and this is it. It is a rational equation because it has fractions. Two reasons, not just one. Because it has fractions and it has x in the denominator. This is not a rational equation. This is a linear equation. It's 0.5x plus 3 equals 0.25x. This is not a rational equation. It doesn't have x in the denominator. But this one is. It's a rational equation. Good. So let's work on this. 2 minutes. In the meantime, I will also type it in. We'll type it in on Wednesday as well, but I'm gonna type it in. I am going to show you the method I like to present in solving rational equations. Of course, any method that is legitimate is acceptable. Let me know when you're ready. Again, if you give yourself too many zeros, it means that you can be successful in this class, but you have to set time aside every day, and you will be successful. But you have to be aware now of the difficulties of this course, so you can plan ahead and set aside time every day for this course. Okay, do we have an answer? Anyone?
X is equal to 6 and negative 3.
Don't be afraid to be wrong. We all make mistakes. So, anyone else? Other answers? Okay, so are we ready to work on this together? Okay, very good. Here it is. This is the method I prefer. First, I move everything to one side, and I, of course, have to factor the denominator. So I move this term to the other side. When we move a term from one side to the other of an equation, we only change its sign. That's the only thing that changes. Of course, I have to factor the denominator because I need to find what next? The least common denominator. That's the next step. Least common denominator. Good. Before I find the least common denominator, I notice a few things. Number one is that this is a factor, and this is a factor, and they have, number two, they have nothing in common. So there are two factors, and this one is also here, and this one is here. So there are two different factors, and they have nothing in common. Number three, if you want, I will have to state two restrictions. One restriction for each different factor, for each factor. What are the restrictions and why I need to state restrictions?
3 and 0.
Why do I write 0 and 3? Why x can never be 0 and 3? Right, because a fraction with a 0 in the denominator is called undefined. So a number not 0 divided by 0 is called undefined. That's the reason why I have to state these restrictions. Perfect. Then I find the least common denominator, which is,
X times F.
of course, all different factors must be present in the LCD, in the least common denominator. Good. So now I ask myself several questions. Here's the first question I ask myself. X minus 3 was multiplied by what? Which means I make myself a note. Listen, I'm talking to myself now. You decided to multiply the denominator by x. You cannot do it unless you do the same thing to the numerator. If you multiply the denominator by x, you must multiply the numerator by x. Otherwise, you change the value of the fraction. If it's 1/2, I cannot say it equals to 1/6 and just multiply the denominator by 3. I have to multiply the numerator by 3 as well. Perfect. Now, what about this? Yes. And what about this? Nothing, preferably 1, or you don't write anything. Good. Now, can anyone dictate the numerator of this new fraction we have? So 2x squared, I agree. Negative 6 times x, I agree. But negative 6 times negative 3, I don't agree. Exactly. I was expecting that. You found their mistakes.
Yeah.
Good. It's just one, but it's a big one, right? So what do I have to write?
Positive 18.
Very good. And then?
Minus 18.
Very good. These two go away. So now the fraction is 2x squared minus 6x divided by x times x minus 3 equals, stop for a moment please, and allow me to ask you a couple of questions. Can I write 5 as 5 over 1? Can I write negative 10 as negative 10 over 1? Can I write 0 as 0 over 1? Can I write x over 1 as x, or x as x over 1? So can I write 0 as 0 over 1? That's what I'm going to do. Why? This is still a rational equation, but it has a very special property, and it has a special name, which this did not happen here. This is not that. I have 3 fractions. But when I have just one fraction on one side, the equal symbol, and one fraction on the other side, this has a special name, and I cannot forget it because only in this I can perform the next step. How is it called? A fraction on the left-hand side of the equal symbol, and a fraction on the right-hand side of the equal symbol. It's called a It is a proportion. Very important. Why? Because only in a proportion I can do what? Thank you. Only in a proportion I can cross multiply. If it's not a proportion, I cannot cross multiply. So then, 2x squared minus 6x multiplied by 1 must equal exactly this product, 0. Okay, I see that I can divide both sides by 2 without changing the solution, and I'm going to do that. So this is x squared minus 3x equals 0. And now I know how to solve this. How? Factor out what? Exactly. What is left? Good. How many solutions does this have? X equals
0.
excellent. Good. And I'll say not so fast. Why? Why am I saying that? Right. Right. Because x cannot be, where is it? Because x cannot be 0 and x cannot be 3. So I will say, what about this equation? Exactly. No solutions. This is a contradiction. The left-hand side will never equal the right-hand side. Okay, so here's the power of Maple. I named this equation F. I decided to use F. I can use G. What letter do you want? You want I? I may be confused with the imaginary unit. I wouldn't play with I. So give me anything else.
R.
R. Very good. So I named R 2 times x divided by x minus 3 minus 6 divided by x minus 18 divided by, in parentheses, of course, x squared minus 3 times x, close the parenthesis, equals 0. And of course, the semicolon. Is this our equation? Okay. Now I want to say solve. And I want you to solve R for x. Don't forget the end. And press enter. So, what do we conclude? No solution. It should have given me just a maybe it doesn't like R. It should have just given us F with no answer. Nope, it doesn't. Okay.
Is this the steps?
I'm sorry?
This is the steps?
No, that was a previous example, and this is just the name that I gave to the equation, and then I asked to solve. That's the syntax for solving an equation. Yep. Yep. Very good. Moving on. So we chose D to graph. Let's graph it. What type of function is this? And let's list those. So what about the first one? What type of function is the first one? I couldn't hear. I'm sorry. Yes, of course. Thank you. The second one.
Exponential.
Exponential will be something like this or something like this. Quadratic, yes. That's okay. Good. Next one. Does it have a ratio? No.
Radical.
Radical. Square root. Very good. Next one that we picked. Of course. Absolute value function. Good. And the last one. Cube root. Cube root. Very good. Yeah, I decided to name this new equation like this because it should give us something with no answer. Here it is. Okay, so it's better to name the solution because otherwise it doesn't give us anything, and I would rather see something. So it gives, so the solution of this equation for x, solve for x, I denoted by q. And then I asked, okay, what is Q? In other words, perform the operations. And Maple did, and did not give us anything. So the reason is because the equation has no solutions. So I should name the solution. And then it will give us a blank. And that's better than just giving us a blank from the beginning. So we are graphing the absolute value function. Okay, 1 minute. Do we need more time? Okay, so let's start. What do we know about the absolute value function? How does it look?
It's a big shape.
Yes, very good. So I already know that the absolute value bisects the first and the second quadrants. This is the absolute value of x. And I know what the absolute value of x minus 3 will do. What will happen to this graph in order to get the absolute value of x minus 3 for now? What do I have to do to it?
Go down 3.
Careful. I'm changing x. I'm changing x into x minus 3. It cannot be an up and down. When I change x into x minus 3, it can be left or right. So where does it go? It goes to the right at 3, exactly. So right here at 3, so the green graph, I'm sorry, it's not green. The red graph is the absolute value of x minus 3. Good. And now, what is the next step that I have to perform on this function, which is the absolute value of x minus 3, in order to get the absolute value of x minus 3 minus 2? Now I'm not changing x. Now I'm changing y. As you see, x minus 3 is the same, down 2 indeed. So the graph will come here. It's possible. Now, in order to be exact, I will have to find the x and y-intercepts. I will say when x is 0, 0 minus 3 is 3. I meant to say is negative 3, and absolute value is 3. 3 minus 2 is 1. So y equals 1. So 0, comma 1. And when y is 0, then I have 0 equals the absolute value of x minus 3 minus 2. I'm going to move 2 here or reverse it. It doesn't matter. The absolute value of x minus 3 equals 2. And as we know, this equation has two options. What are the options? What can I have here for the absolute value to be 2? What can this number be? 15? No, because, right, the absolute value of 15 is not 2. So what could this be? Exactly. Indeed, x minus 3 equals 2, and x minus 3 equals negative 2. So this I know is x equals 5, and this I know is x equals 1. So I have 5, comma 0, and 1, comma 0. So these are the exact ordered pairs. Not a problem. So 0, comma 1, 1, comma 0. And I know this point is very clear. There is no discussion here. It's 3, comma negative 2. Absolutely. And the other one is 5, comma 0. 4, 5. So this must be the graph. And this is, I always have to label what I'm graphing. Oops. Okay, so let's look at the command for plot. Okay, here it is. Plot in parentheses. I will have a handout for you for Wednesday. You don't have to write this down. Left-hand side, left parenthesis, absolute value of x minus 3 minus 2. This is the function. I want to see x between left-hand side negative 2 till 7, and for y, minimum negative 6, maximum 6. As you see, there are 2 dots, just 2 dots. And then I press enter. And here it is. Crosses at 5, 4, 5, exactly in the middle, right here between 4 and 6. It crosses at 1. It crosses at 0, 1. And of course, this must be 3 comma negative 2. Any questions? Okay, moving on. Next page. I would like you to, let's identify these two also. So this is what type of function? In F. What do you think? Does it have a ratio? Does it have x in the denominator? What can it be? Indeed. Rational. Okay? And this is the inverse tangent. The inverse tangent. Okay. Graphing a piecewise defined function. Extremely important. Finding the equation of a line. Perform calculations on such an expression. And then solving some trig equations. What would you like to continue? We have left about 25 minutes. What would you like to continue with from these? Graphing the piecewise defined function, finding the equation of a line, simplifying, and trig equations. Which one? Very good. Okay, so let's do that. So let's think for 3 minutes. Number 5, the piecewise defined function. I'm going to copy it here. This is a very important topic in calculus, being able to graph a piecewise defined function, because we are going to look at limits for such a function, differentiation for such a function, and even integration for such a function. Okay, so let's start working on this together. when I'm asked to graph a function, what is the first thought that comes to mind? The very first step. If you give me a function, say, hey, graph this, what is my first thought? What will I have to do first or think of first? Excellent. Absolutely. If I don't have the domain, I don't know what to plug in. I may not even know what type of function it is, because obviously this is a function created by three functions. It's one function, but it has three different branches. When will this be applied in real life situation? Can anyone give us an example? Here's an example. The tax code is a piecewise defined function. If somebody makes between, I'm just making numbers up now, I don't remember the tax code, but if somebody makes between 50,000 and 70,000, it will pay 10% of that. If somebody makes between 70,000 and 100,000, will pay 15% of that. That's what it is, a piecewise defined function. Can we think of another example of a piecewise defined function? Maybe it's not applicable anymore because I guess everybody now is on a unlimited plan, phone plan. But if you're not on an unlimited phone plan, if you talk between 0 minutes and 1,000 minutes, you pay $30. If you talk between 1,000 minutes and 2,000 minutes, you pay $35. This is a piecewise defined function as well. It's another example. Okay, so the domain. I can't do anything without the domain. Good. So first of all, I'm looking at this, and I imagine the interval is between -infinity and 0. Do you all agree? So if I look at this or I look at this, it's the same thing. Yes or no? Yes? Perfect. Now if I look at this, or what? What is the interval notation for this? Very good. Between 0 and 2 is very clear. Greater than 0, less than 2. No questions, right? Is that okay? What about the last one? So if I look at this or I look at very good, excellent. And what do I do here? Very good, excellent. So we agree. Now this may be somewhat easier to identify the domain. So here's what I see. I see everything between -infinity and 0. I see 0. I see everything between 0 and 2, not 2. And then I see from 4 to infinity. One more time. From -infinity till 0, everything. I see 0. I see everything between 0 and 2. I do not see 2. And then I see from 4 to infinity. So what is the domain of this function then? Exactly. -infinity to 2, indeed. Union. It's right here. 4 to infinity. Very good. That's what I have to present in the chart. So -infinity to 4 infinity, parenthesis at 2, facing this way, bracket at 4, facing this way, and nothing here. Good. I also have to put in the chart this value, which is 0. Mandatory. It has a bracket facing this way, and it has a parenthesis facing this way, and they're touching. You will see the use of that in a minute. Although I have the function right here in front of me, I would like you to tell me which function, which piece I will use between -infinity and 0. 2. Excellent. Which piece will I use between 0 and 2? I know it's right there, but I want to write it. again, to make sure I understand what I'm doing. 1 minus x squared. And now which piece or which function will I be using for values of x between 4 and infinity? It's clear now, right? Okay, perfect. So now whatever I pick, let's say -2, I have to write 2. If I pick 0, I have to write 2. If I pick -5, I have to write 2. If I pick -10, I have to write 2. It's all 2. There's nothing else. Good. Now here, I'm going to plug in 0. And you should be appalled, right? Wait a minute. You cannot plug in 0 in this function. 0 is here, but not here. True. Bear with me for a moment. So let's plug in 0. What do I get? 1. Let's also plug in 1, because when I set 1 minus x squared equal to 0, I get plus or minus 1. Minus 1 is not in that piece of the domain, but 1 is. So I have to use it. What do I get? Good. And please plug in 2, and you should be appalled again and say, no, 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 you can't plug in 2. Bear with me and I'll explain. So please plug in 2 in this function and tell me the answer. Excellent. So now please plug in 4 in the last piece. Good. And plug in another number that will give us, let's say, 4. Good. Excellent. That's all we need. We are ready to graph this function. Careful, you cannot extend the branches in any direction you want. The branch on your left cannot overlap with the middle branch, and it cannot overlap with the branch on your right, and vice versa. So for each piece of the x values, I have a different function to graph, and they cannot overlap. Okay, so here I'm graphing -2. Let me use a different color. At -2, the function is 2, and this is a full point. At 0, the function is 2, and this is also a full point because of the bracket. So the graph of this function is this. Are you with me so far? Okay, I'm going to use a different color for the middle, but doesn't mean it's a different function. The whole graph will be one function in 3 pieces. Okay, ready? Here I have 0, 1. So 0, 1, because of the parenthesis, it will be an open point. 1, 0 is in the middle. I can't change that. And 2, -3 is this point. It's also an open point because it's a parenthesis. I don't have a bracket. Now I have to think for a moment. I have to connect these 3 points, 1, 2, 3. What type of function is this? So I know how to connect them. It's quadratic. Very good. So I'm going to graph a quadratic function because 1 minus x squared is quadratic. Perfect. Notice that I cannot extend the quadratic function to the right of 2 or to the left of 0. I can't. This quadratic function has to exist only between x values of 0 and 2. As well as this function exists only for x values between -infinity and 0. Now this function will exist only between 4 and infinity. So I have to graph 4, 3. I'm going to use a different color. So this was 2, 3, 4, 4, 3, right here. This is a full point because of the bracket. And this was 4, 5, 6, 7, 8, 9, 10, 11. Of course, my graph is not perfect. And I got this. And now I have to stop and think. How do I graph this? It's not linear. It's not quadratic. What is it? It's radical. How do I graph a radical function? It's not a straight line because it's not a linear function. So yes, the square root of x looks like this. So that's the shape. So I have to graph this. Now, if I ask you, what is the range of this function? What would you say? From the smallest y value, which is not attained, it's not taken, in other words, -3, but with an open parenthesis, comma, where does it go? How far? Till 2, union, from, very good with the bracket, to infinity. Very good. Excellent. Yes, please.
Wait, -3 to 2. So.
Yes, yes, till 1. Yes, thank you. Yeah, I skipped this portion. Very good, thank you so much. Thank you. So -infinity to 1, union 2. 2 alone, one number. Thank you. Thank you very much. Of course. Okay. I am copying, because I created this for you already, so you can see it. Oops. Oh, no, you can see anything. Okay. For piecewise defined functions, the syntax is this. Piecewise, x less than or equal to 0 is 2. Between 0 and 2 is 1 minus x squared. For greater than or equal to 4 is the square root of x plus 5. I named this function f. So here it is. And now, because I've done this before coming to class, so I don't have to type this in and you watch me type it in. Oh, where did it go? Where did it go? Right here. Okay. So, if I don't put this additional information, the graph will look like with the graphing calculator will connect vertically the branches, and that's not allowed. So, here it is. Even Maple has to think about this. Here it is. So you can see clearly here that this is an open point, this is a closed point. However, this should have been, no, this is a closed point and this is an open point. And this is an open point. So be very careful. You see a gap between 2 and 4. The function does not exist.
At the bottom of the,
Yes, both have to be open. Yeah. So careful. Careful with that information and detail. It's very important. Okay, we have about 7 minutes. Let's choose one more problem. Any questions on this? Yes, please.
on the range? Or,
Yes. Yes, it's between -3 and +1. There is a complete gap between +1 and +2. And this is just one number. So I have to put it in braces. I cannot include it as a open parenthesis or a closed parenthesis because it's just one point. So see, I can cut this function here. Here I don't have a value. Yes, 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 yes. No. No, 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 no. Yes, just for 2. No, 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 no. And starting from 3 is continuous again. So from 3 to infinity, correct. From -3 to +1, correct. And this is just one additional number alone. If it's just one point, I cannot use interval notation or brackets, in other words, or parentheses.
Okay, so the one should be in a bracket. But it shouldn't be in
One is in a parenthesis, yes.
a-
No, no. Oh, that's what your question. Yes, yes,
Yeah,
yes.
so-
Yes, that's what I meant. That's what I meant. Yes, I'm sorry. It's from here. Yes. Thank you. It is. So 1 is open. -3 is open. 2 is separate because it's not part of any interval, and then 3 is closed and to infinity. Yes. Thank you. Good. So as I said, we only have 5 minutes left. And would like to choose. Would you like to do the simplification, or would you like to determine the equation of the line? Which one?
Let's try A.
Which one?
Right on A. For number 8.
8a?
Yes.
Very good. Okay, so let's do that. That's what type of equation? I know it's an equation because it has the left-hand side, it has the right-hand side. What type of equation is this? So it is your responsibility to finish the rest of the problems for Wednesday. And Wednesday we'll practice these problems with Maple. Okay, so what type of equation is this?
It's not
No.
trigonometry.
Yes. It's a trig equation. Very good. It's a trig equation. Absolutely. Perfect. Good. So now let's think. Let's do some thinking. Can you please tell me the signs for sine in the unit circle? No, no, no. The signs. Just the sign. So what is the sign of sine in the first quadrant? The sign of sine in the second quadrant. The sign of sine in the third quadrant. And the sign of sine in the fourth quadrant. Negative. Okay. Obviously, if they are the same, they must have the same sign. Very good. So now let's discuss cosine. Sorry. So forget about sine for a moment. What is the sign of cosine in the first? What is the sign of cosine in the second? What is the sign of cosine in the third? And what is the sign of cosine? Very good. So, perfect. So then what are the options? Obviously, something, if they are equal for any angle, something in the first quadrant, and definitely something in the third quadrant, correct? Is there any angle for which sine and cosine are identical?
First question, 45.
Perfect. So here we have x equals pi over 4 or 45 degrees plus 2 pi k, where k can be 0, plus or minus 1, plus or minus 2, and so on and so forth. So in other words, I'm saying this, and also this, and also this, and the other way around. Good. Is there another option? It must be. So it's going to be this angle, right? So 45 plus 45 plus 45 plus 45. There are two 45s here and two 45s here and another one here. So 5 pi over 4. Yes. Plus 2 pi k. We can also answer this with pi over 4 plus pi k. So these two can be condensed into one solution, as x equals pi over 4 plus pi k, meaning pi over 4 plus 180. Pi over 4 plus a multiple of pi over, a multiple of 180. So 1 or 2, 3 or 4, and the other way around. So this is the condensed form. And I do have, let me see. As I said, I created this file for you already. Let me see if I can bring it up. They're hiding from me today. Oh, okay. I know. But where is it? It's hiding. Well, I don't know.
You gotta minimize that screen.
Oh, hiding from me. Really?
See that one down in the left hand. No, that one in the left. Let's watch this minimize the screen.
No, I may not have that. That's okay. I can start another sheet. So I'm going to call F the equation sine x. I need parentheses and a semicolon. Sine x minus cosine x, and it has to be in parentheses. And also this has to be in parentheses. Okay, so I think I'm okay now. So here's the equation, and then I'm going to call Q or G or D, or it doesn't matter. Solve F for x. Here it is. And it gave us the answer. Any questions? As I mentioned, yes.
So the program only gives you like a certain range.
It only gives you one solution. Then you have to think in terms of all possible solutions. There may be a way I have to research that. There may be a way in which it gives us all possible solutions. I would have to look it up. Very good. Any questions? Any questions? Yes.
So K